So in this chapter, techniques that we discussed for allowing us to solve equations that look a little bit more complex are looking inside. We also looked at rewriting things and also looking inside, rewriting, and working backwards. I think were the things that they called the things that the book pulled out. Part of that is we came up with this idea of fraction busters, which is kind of rewriting what an equation looks like so that you don't have to deal with the fractions. So I have three equations here. These aren't the only three possibilities, but these are things that were on this test and things that we're likely to continue to see and practice. And again, as I said, there's a great deal of extra practice over here. So you can see I've got lots of different equations and the solutions off to the right. These were just all, I just wrote these and just generated the answers in OneNote. You know, OneNote, the books, of course, go on forever, so just feel free to scroll over, write down one of those questions, and then verify that you're able to consistently and predictably get these answers, right? It's a lot of it is, of course, checking answers to verify that you're correct, but by being really careful in our handwriting and how we structure things, we kind of get to a point where I guess we never eliminate the need to check our work, but we spend a lot less time trying to figure out where our errors are because well-written math it's easy for us to see things and to find errors if they do indeed exist. So on this first question, the big idea that I want to communicate here is I know, right, that it is the square root of 144 that produces an answer of 12. And if I'm not really proficient with knowing what my square roots are, if I take the number 12 and square it, I do get 144. So I know that this expression inside that I've kind of highlighted in blue, this expression 2x, I don't know why I'm using that. I should use the red. It's not this 2x minus 44, right, has to equal 144. Again, if the thing that's highlighted in blue was 144, then I would precisely get 12 when I took the square root of it. So what I'm doing here is I'm just asserting that I want to make that thing exactly 144. I'm saying 2x minus 44 must be 144, and if it is, then I'll force the correct solution here. So I'll begin by adding 44 to both sides, right? That gives me that 2x is equal to 188. And if I divide both sides by 2, I know 100 divided by 2 is 50, and 88 divided by 4, I believe, is 94. So I believe this becomes the number 94. Now again, it's so quick to check. It's just worth doing all the time, right? So I'm just going to go ahead and grab the square root symbol, and I'm going to go 2 times. Whoops, that's subtraction again. I got to get the right 2 times 94, and then I'm just going to subtract from that the number 44. And when I press enter, you can see I get exactly 12. Yeah, so 2 times 94 minus 44. The square root is 144, and it gives me an answer of 12 when I take the square root. Okay, next question. So this is the one that I think probably is most problematic for us, and it involves this idea of rewriting equations. So the thing I want us to focus on is I know something about the number 25 in terms of a base of 5, right? 25 is 5 squared. 5 times 5 is 25. So what I can do is I can rewrite portion of this equation. Instead of writing 25, I can rewrite it as 5 squared. So again, everything that I just wrote right there, right? This whole thing is what is equivalent to the 25. That's all this is. This is the number 25. And you can see the rest of this equation is if you take 25 and raise it to the x minus 5 power, right? That's what the right hand side is. The left hand side is 5 raised to the 3x plus 1 power. Now, if I have a power raised to a power, right, a power raised to a power, it involves multiplication, right, the law of exponents. So for example, if I had 2 raised to the third power and I raised that to the fifth, if I was to write out 5 copies of 2 to the third, right? It would be 2 to the third, 2 to the third, 2 to the third, 2 to the third. There'd be 5 of those. And then count all the factors of 2, there would be exactly 15 of them, right? So I don't do that all the time. I just say, oh, this is the same as 2 to the 3 times 5 power, because I know that law of exponents, 2 raised to the 3 times 5 power. Well, the same thing here, right? I'm going to multiply this 2 times x minus 5. So that right-hand side of the equation can become 5 raised to the 2x minus 10 power. And over on the left-hand side, it's still 5 raised to the 3x plus 1 power. Now, these are exponential equations. There's a variable in the exponent, and our tool for solving them at this point is to attempt to rewrite it so that the bases are identical. And then our reasoning goes something like this. If the bases are both 5 on the left and right hand side, the only way that these can truly be equal to each other is if this particular base, right, if the 3x minus 1 is exactly the same as this base. So it's not like I'm canceling out the 5 or anything like that. I'm just saying, look, this exponent, rather, this 3x plus 1 exponent must be the same as this exponent. And if they are equal to each other, right, then 5 raised to that power, right, they will also be equal to each other. So to solve this, I'm going to subtract I'm going to subtract 2x from both sides, I guess. So I'll get x plus 1 is negative 10, and then I'm going to subtract 1, so x should be negative 11. Now again, maybe a little bit more difficult for me to check this answer. I'm going to anyways. I'm going to go ahead and raise 5 and then go to the power of, and again that's just this little up arrow, same as the keyboard when we're using OneNote. You hit shift and 6, I think, to get this up arrow. So 5 raised to the power of, and then I'm going to just go ahead and type, what did I say it was, negative 11. So I'm just going to go 3 times, and then I'm hitting the negative there, not minus, 3 times negative 11, and then plus the number 1. And I'll press enter, and you can see I get this very, very small number, right? In scientific notation, that's 4.29 times 10 to the negative third. If you're wondering how to read that, that's just times 10 to the negative 23rd. Now let's see if I get the same thing over on the right hand side. So again, I'm just going to take 25 and I'm going to raise it to the negative 11 minus 5 power. And when I do that, I get exactly the same value, right? So pretty confident that x equals negative 11 is the solution to this equation. I could plug 11 into both these also and see that it makes the exponent as well, which may be a little bit nicer, not quite as big a numbers to compare. But anyways, that's the big idea. And like I said, I've provided you with many examples of problems that are like that. Every single one of these is rewrite these so that the bases are the same. And it doesn't have to be just those 5. You could make up your own. The one thing that I'm always picking out is I have to make these problems work so that you can change the bases to be the same. So if you're going to write your own problems, be aware of that. And also you can just ask me, Ms. Roberts, can you give me a couple more, because I think I got this but I want to be 100% correct. All right, and then our last question is this idea of fraction busters. Big idea is, of course, if you have equal things and you multiply by equal things, you get equal things. And the goal, the idea here is that I want to multiply this entire equation through by a value, right, such that all of these fractions would be busted up. And I can see that the first denominator has a factor of 2 and x. The next one has 2 factors of 2. It's the number 4, right? That's 2, 2. And then the last one has a factor of x. Well, it turns out the lowest common denominator for all of those would be, I believe, 4x. And if I just write this here, right, 4x is what I need to eliminate all of the fractions, right? All these fractions are going to be gone. Now there's a total of 3 terms here that I'm looking at. There's 2 terms on the left-hand side. The 5 over 2x is a term, and then the 2 over 4. By the way, that's a half, right? That's another way I could do this. I could just change that to 1/2 first and not have to worry about multiplying by 4. Not a bad idea, but I'm here. I'm not going to do that now. And then the right hand side has is just a single term of 5 over x. So what I do next is I just write the equation again, but I'm very intentionally pushing factors of 4 and x in each of the numerators, plus 2 times 4x over a 4, and then that equals 5 times 4x all over x. So again, as I look at this, you can see my goal was to take and just to land 4x in each one of these numerators, and you can see there's the 4x, there's the 4x, there's the 4x. And when I'm looking at the rest of them, I'm just verifying visually that nothing else changed, right? Everything else is exactly the same as it was before. I've just successfully multiplied both sides by 4x. Now, as I start to look at this, there's clearly some giant ones here that we can play with. And I don't know that I'll explicitly write them all out, but I will point out that obviously this is a giant one, right? And then the 4 over 4 is a giant one, and then again there's another x over x. And you can see there's one that I missed, right? 4 divided by 2 is 2, so this is really 2 times 2, so there's like a giant one with that, right? If the 4 is taken out of the mix. Or I could just, there's a lot of ways I can deal with that, right? 20 divided by 2 is 10. So anyways, the upshot of it all is that first term becomes 5 times 2, and that's it. So it's just a 10, plus I've got a 2x, and over on the other side I've got 5 times 4, which is the number 20. If I take away 10 from both sides, I've got that 2x is 10, divide by 2, x has to be 5. So again, this is my solution, and I would write it down below in the line, but I want to verify this and make sure that I really do get the same thing. So over on the left hand side, I'm just going to go 5 divided by. Now, a tricky thing, if you're going to do a product, you need to make sure that you put parentheses around it if the product's in the denominator. I'm just going to go ahead and manually do this. I know this is 5 divided by 10, which is great. That's the number 1/2. No, thank you. So what I'm going to do is that's just 5 divided by 10, which is a half, and then I've got plus another half, right? 2 divided by 4, which is clearly a half. And then if I press enter, I feel goofy that I've typed this into a calculator because a half plus a half is 1. And over on the right hand side, yeah, 5 divided by 5 most definitely is the number 1 as well. So when x is 5, both the left hand side and the right hand side of this equation become 1. So that is indeed the solution.